Let's solve a trig equation. We see the variable term right here. There's only one trig function in this equation, so it's pretty easy to isolate that variable term. We'll subtract root 2 to the right-hand side, and then we'll divide by 2. All right. Now we need to look at a unit circle. We need to figure out where on the unit circle the cosine function has a value of negative root 2 over 2. So that puts us on the 8-sector unit circle, and these two terminal points will correspond to angles that have a cosine value of minus root 2 over 2. So this tells us that the angle, which is 3 theta, is equal to 3 pi over 4 plus 2 pi k. That gets to all of the coterminal angles that also have a terminal point in quadrant 2. Or we're equal to 5 pi over 4 plus 2 pi k. So we've figured out what 3 theta is equal to. We haven't solved for theta yet. Solving for theta is not too hard, though. We divide both sides by 3. And that will give us 3 pi over 12. And we're dividing all terms on the right by 3. There we go. Now, that can be simplified a little bit. So let's rewrite this as pi over 4 plus 2 pi over 3 times k, or this one can't be simplified. 5 pi over 12 plus 2 pi over 3. All right, so now this is a list of all solutions. This gives us all solutions. And there's an infinite number. Oop, I forgot my k. As long as there's a k, there's an infinite number. So this k is an integer. So what this means is that our first angle over here is pi over 4, and then we're going to add multiples of 2 pi over 3 repeatedly. And that will give us an infinite number of answers that are all solutions to this. 5 pi over 12, add multiples of 2 pi over 3, and that will give us a whole nother group of solutions for this equation. Now, a lot of times you're asked to find the solutions in a particular interval, usually 0 to 2 pi. So if that's the case, what we have to do is go back up and look at these groups of solutions and figure out all of the ones from each group that land in the interval 0 to 2 pi. The first one is certainly pi over 4. And then we have to add 2 pi over 3 to that. To add 2 pi over 3 to that, it might be helpful to get a common denominator. Let's see, where can I squeeze that in? Well, maybe I'll just put it right over here. So we have 3 pi over 12. That's the pi over 4. And then 2 pi over 3, if I multiply top and bottom by 4, we'll get 8 pi over 12. And that k is still there. All right, so I'm going to be adding 8 pi over 12. That gives 11 pi over 12. And then I want to add 8 pi over 12 again. That gives 19 pi over 12. If I were to add 8 pi over 12 again, that would give us 27 pi over 12. But that's more than 2 pi. 27 divided by 12 is more than 2, so I've gone too far. So I don't need that one. I also will have 3 solutions from this family, from this group of solutions. So we'll have 5 pi over 12. And then we want to add 2 pi over 3. And 2 pi over 3 is the same as 8 pi over 12. So we're going to add 8 to the 5 and get 13 pi over 12. Add 8 to that, and we get 21 pi over 12. If you were to add 8 again, you would get 29 pi over 12, and 29 over 12 is more than 2, and that's outside of this 2 pi endpoint here. And one pattern that we'll notice, is that when you look at your unit circle, if there are 2 solutions here, and you're dealing with a multiple angle, if you take the coefficient of the multiple angle, in this case it's 3, and you multiply it by the number of solutions that you see on your unit circle, that will tell you how many solutions there are between 0 and 2 pi. So we get these 6 solutions. Fun.